When Japan entered World War II with the most elite pilots in the world, their rigorous training program produced 15,000 exceptional aviators through years of intensive preparation. What they didn't anticipate was America's industrial approach to pilot training that would graduate 193,440 airmen in the same time frame, fundamentally transforming aerial warfare through sheer numbers and revolutionary training methods. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. March 8, 1941. Imperial Japanese Naval Air Training Command, Kasumigaura Air Base, Japan. The morning mist rose from Lake Kasumigaura as Flight Petty Officer Hiroshi Yamamoto completed his 847th training flight in the Nakajima A-6M Type 0 fighter. His logbook recorded 1,240 flight hours accumulated over 18 months of the most rigorous aviation training program in the world. Japan's pilot preparation demanded perfection that few could achieve. Commander Minoru Genda stood on the observation tower watching 12 trainee pilots execute precision formation flying that would shame veteran aviators from other nations. Each pilot had survived elimination rates exceeding 90%, representing the culmination of Japan's philosophy that quality superseded quantity in aerial combat. The Imperial Japanese Navy's training doctrine produced pilots with skills that bordered on the supernatural, but at a cost that would prove strategically unsustainable. The Kasumigaura facility represented Japanese aviation training at its most sophisticated. Established in 1922, the base had evolved into a comprehensive flight training complex covering 2,400 acres with 4 concrete runways, advanced simulators, and maintenance facilities that supported 240 training aircraft simultaneously. The program duration averaged 24 months from initial selection to operational assignment, with washout rates that eliminated 8 candidates for every pilot who graduated. Flight training began with 6 months of basic military instruction that tested physical conditioning, mental discipline, and absolute dedication to the Emperor. Candidates endured daily calisthenics beginning at 0430, followed by academic instruction in navigation, meteorology, aircraft systems, and tactical doctrine. Only those demonstrating complete mastery of theoretical knowledge advanced to actual flight training, which commenced with 40 hours of primary instruction in the Yokosuka K-5Y biplane trainer. Lieutenant Saburo Sakai had graduated from Kasumigaura in 1938 after 22 months of training that nearly broke his spirit multiple times. His instructors demanded perfection in every maneuver, accepting no deviation from prescribed flight procedures. A single navigation error during cross-country flights resulted in immediate elimination. Aerobatic sequences required precision that left no margin for error. Formation flying demanded coordination that seemed impossible for human pilots to achieve. Preparing and narrating this story took us a lot of time, so if you're enjoying it, like this video. It means a lot to us. Now, back to the story. The Japanese training methodology emphasized individual excellence over mass production. Each instructor worked with no more than 6 students, providing personalized guidance that identified and corrected every weakness in flying technique. Students flew multiple sorties daily, accumulating flight experience through repetition and gradually increasing complexity. Advanced training included night flying, bad weather operations, and combat maneuvering that prepared pilots for every conceivable operational scenario. Captain Mitsuo Fuchida, who would later lead the Pearl Harbor attack, had completed the most advanced training available to Japanese pilots. His curriculum included 380 flight hours across 12 different aircraft types, specializing in dive bombing, torpedo attack, and fighter tactics. The training regimen produced pilots capable of executing complex attack profiles with mathematical precision, but required resources that limited Japan's total pilot production to approximately 100 graduates per month across all services. But 7,000 miles across the Pacific, American aviation was preparing to revolutionize pilot training through industrial methods that would dwarf Japanese production capabilities. The Army Air Force's Training Command had established flying schools across the continental United States using standardized curricula and mass instruction techniques adapted from civilian flight training programs. The American approach prioritized rapid throughput over individual perfection, gambling that adequate training provided to large numbers would prove more effective than exceptional training limited to small groups. March 15, 1941. Randolph Field, Texas. Colonel Harold George reviewed training statistics that seemed impossible by traditional aviation standards. American flight schools were processing 500 student pilots simultaneously at each major facility, with graduation rates approaching 75% compared to Japan's 10% success rate. The fundamental difference reflected contrasting philosophies. Japan sought to create aviation artists, while America aimed to produce competent pilots in unprecedented numbers. The American training revolution began with primary flying training conducted at civilian contract schools scattered across the southern United States. Students received 65 hours of flight instruction in Stearman PT-17 biplane trainers, focusing on basic flying skills rather than advanced combat techniques. The curriculum emphasized standardized procedures that enabled rapid instruction of large groups, sacrificing individual attention for production efficiency. Chief Flight Instructor Robert Johnson had adapted automobile assembly line principles to aviation training at the Spartan School of Aeronautics in Tulsa, Oklahoma. His methods processed 200 student pilots every 10 weeks using standardized lesson plans and rotating instruction that maximized aircraft utilization. Students progressed through predetermined training phases regardless of individual aptitude variations, with remedial instruction available for those requiring additional practice. Basic flying training followed primary instruction, conducted at Army Air Forces bases using North American AT-6 Texan advanced trainers. Students received 70 hours of military flight training, including formation flying, instrument procedures, and basic gunnery. The instruction emphasized practical skills necessary for combat operations rather than the aerobatic precision demanded by Japanese training programs. American pilots learned to fly effectively rather than perfectly. Advanced flying training specialized students for specific combat roles: fighter pilots, bomber pilots, or transport pilots. Fighter training required an additional 75 hours in advanced trainers, focusing on air-to-air gunnery and tactical formations. Bomber training emphasized navigation, formation flying, and crew coordination skills. The specialized instruction prepared pilots for specific operational requirements without the comprehensive training that characterized Japanese programs.
Lieutenant Colonel Claire Chenault had observed Japanese pilot training during his service in China, recognizing both the strengths and limitations of their meticulous approach. Japanese pilots demonstrated exceptional individual skill, but their training emphasized rigid adherence to prescribed tactics that limited adaptability in combat. American training, while less intensive, produced pilots capable of improvisation and tactical flexibility that would prove decisive in extended combat operations. The first significant expansion of American pilot training came in April 1941 with the establishment of the British Commonwealth Air Training Plan facilities in the United States. British, Canadian, and Australian student pilots joined American training programs, bringing international perspectives that enhanced instruction quality. The combined programs processed over 1,200 students monthly across 30 major training installations. April 20, 1941. Luke Field, Arizona. Major Jimmy Doolittle supervised advanced fighter training that demonstrated American tactical innovation. Student pilots practiced high-speed passes, vertical maneuvers, and energy fighting tactics that differed fundamentally from Japanese training doctrine. American instructors emphasized aggressive offensive action rather than the defensive precision favored by Japanese methods. The technological advantages were becoming apparent as American training incorporated advanced aircraft and equipment unavailable to Japanese programs. Link trainers provided instrument flying instruction without consuming flight hours or risking aircraft accidents. Radio navigation equipment taught students to operate in weather conditions that would ground Japanese pilots. Advanced gunnery ranges used motion picture cameras to record student performance, enabling detailed analysis impossible with traditional methods. American pilot production statistics revealed the scale of the training expansion. By May 1941, flying training capacity had increased to 1,500 graduates monthly across all specialties, with projections indicating 3,000 monthly graduations by December. The industrial approach was producing pilots faster than Japanese training programs could graduate students, despite American instruction requiring only 10 months compared to Japan's 24-month curriculum. But quantity remained meaningless without quality sufficient for combat effectiveness. Japanese pilots had achieved legendary status through aggressive operations in China, where individual skill often determined engagement outcomes. Captain Hiroyoshi Nishizawa had shot down 36 Chinese aircraft during 6 months of combat operations, demonstrating the superiority that intensive training could achieve. American pilots would need to prove that mass-produced training could compete with Japanese excellence. The first direct comparison came in May 1941, when American volunteer group pilots trained under Chenault engaged Japanese aircraft over China. American pilots, products of abbreviated training programs, initially suffered heavy casualties against experienced Japanese aviators, but superior aircraft and tactical flexibility eventually enabled American pilots to achieve favorable exchange rates, suggesting that adequate training combined with technological advantages could offset individual skill differentials. May 30, 1941. Tuskegee Air Army Field, Alabama. The establishment of the first African-American pilot training program demonstrated American commitment to maximum utilization of available human resources. Japanese training programs excluded entire populations based on social background, while American training expanded to include previously underutilized groups. The inclusive approach multiplied potential pilot candidates beyond levels that Japanese programs could match. Captain Benjamin Davis Jr. supervised training that met identical standards applied to white pilot candidates, proving that competent instruction could develop pilots from any background. The Tuskegee program would eventually graduate 994 pilots, representing additional capacity that Japanese training philosophy could never access. American industrial training methods were expanding both in scale and inclusivity. Japanese training continued emphasizing individual excellence that produced remarkable pilots but limited overall numbers. Flight Petty Officer Tetsuzo Iwamoto had accumulated 1,400 training flight hours before receiving operational assignment, representing investment in individual capability that American programs could not match. But Iwamoto represented one exceptional pilot, while American programs were producing dozens of adequate pilots in the same time frame. The strategic mathematics were becoming inexorable by summer 1941. Japanese training pilots required 24 months and produced 100 graduates monthly, while American programs completed training in 10 months and graduated 1,500 pilots monthly. The production differential meant that American pilot strength would exceed Japanese capabilities within 18 months, assuming both programs maintained existing schedules. June 15, 1941. Maxwell Field, Alabama. The Army Air Forces established the Southeast Air Corps Training Center, consolidating flight instruction under unified command that enabled unprecedented standardization. Colonel Walter Weaver implemented training protocols that ensured consistent instruction quality across multiple bases, eliminating variations that had characterized earlier programs. The systematic approach enabled rapid expansion without corresponding decreases in graduate competency. American training innovation extended beyond flight instruction to include comprehensive ground schools that prepared pilots for complex combat aircraft. Students learned aircraft systems, maintenance procedures, and tactical doctrine through accelerated courses that compressed traditional instruction periods. The integrated approach produced pilots capable of operating advanced aircraft immediately upon operational assignment. The technological revolution was accelerating American training effectiveness faster than Japanese programs could adapt. Advanced aircraft simulators enabled students to practice emergency procedures without risking expensive aircraft or pilot lives. Radar training prepared American pilots for equipment that Japanese aviation had not yet adopted. Radio communication instruction emphasized coordination that would prove decisive in large-scale air battles. July 4, 1941. Randolph Field hosted the largest pilot graduation ceremony in aviation history as 847 newly commissioned second lieutenants received their wings. The ceremony represented industrial achievement that Japanese training programs could never approach, demonstrating American capacity to produce pilots in unprecedented numbers while maintaining adequate instruction quality. Lieutenant William Shomo represented typical American pilot training outcomes: competent but not exceptional flying skills, adequate gunnery proficiency, and tactical knowledge sufficient for combat operations. His 210 flight hours compared unfavorably to Japanese standards, but American training philosophy emphasized practical competence over theoretical perfection. Shomo would later shoot down 7 Japanese aircraft in a single engagement, proving that adequate training combined with superior equipment could achieve exceptional results. Japanese training philosophy prevented adaptation to American production methods without abandoning fundamental beliefs about aviation excellence. Reducing training duration would compromise the technical superiority that made Japanese pilots individually superior to opponents. Increasing class sizes would prevent the personal instruction that developed exceptional flying skills. Japanese training remained constrained by perfectionist standards that limited expansion possibilities.
The first American training casualties came in August 1941, as rapid expansion strained instructor capabilities and aircraft availability. 14 student pilots died in training accidents during a single week, representing losses that Japanese training programs experienced rarely due to more conservative instruction methods. American training accepted higher casualty rates as inevitable consequences of mass production, gambling that overall pilot availability would offset individual losses. August 20, 1941, Columbus Army Airfield, Mississippi. Advanced twin-engine training commenced for bomber pilot candidates, representing specialized instruction that Japanese programs could not provide in comparable numbers. American training was producing pilots for strategic bombing operations that would require hundreds of aircrew members, demands that Japanese training capacity could never fulfill. The bomber training program exemplified American industrial approaches applied to aviation instruction. Classes of 200 students progressed through standardized curricula using identical aircraft and equipment. Instructors followed predetermined lesson plans that ensured consistent training quality regardless of individual teaching variations. The systematic approach enabled rapid scaling that Japanese training methods could not duplicate. Multi-engine aircraft training revealed additional American advantages in aircraft availability and technological sophistication. Training bases operated fleets of advanced aircraft that exceeded the total inventory of most foreign air forces. Students learned on equipment comparable to frontline operational aircraft, ensuring smooth transition to combat assignments. Japanese training often used obsolete aircraft that poorly prepared pilots for operational requirements. September 10, 1941. The establishment of glider pilot training at 29 Palms, California, demonstrated American willingness to develop specialized aviation capabilities that Japanese programs ignored entirely. Glider operations would prove crucial for airborne assault operations, representing tactical capabilities that comprehensive American training was developing, while Japanese programs remained focused on traditional fighter and bomber operations.
Captain Richard DuPont supervised glider training that emphasized precision flying under power-off conditions, skills that enhanced overall pilot competency beyond specific glider applications. Students learned energy management and landing techniques that improved their capabilities in conventional aircraft, demonstrating how specialized training could provide broader benefits. Japanese training programs rarely offered comparable cross-training opportunities. The industrial scale of American pilot training was becoming apparent to Japanese intelligence services monitoring aviation expansion across the United States. Reconnaissance reports documented training facilities that individually exceeded Japan's total pilot production capacity, suggesting American aviation strength would surpass Japanese capabilities through overwhelming numbers rather than individual excellence. October 7, 1941. Pearl Harbor would change everything, but not in the way Japanese planners anticipated. The attack demonstrated Japanese pilot superiority through flawless execution, but also revealed the strategic miscalculation that would doom their aviation program. Commander Mitsuo Fuchida led 353 aircraft in the most perfectly coordinated naval airstrike in history, achieving tactical surprise that validated years of intensive training. But the attack awakened American industrial capacity that would overwhelm Japanese pilot production through sheer mathematical inevitability. Captain Minoru Genda had calculated that destroying American naval aviation in the Pacific would provide Japan with 18 months to consolidate territorial gains before American forces could mount effective counterattacks. The assessment proved accurate regarding immediate tactical results, but completely underestimated American pilot training capacity that was already producing 2,100 graduates monthly. Japanese intelligence had focused on existing American pilot strength while ignoring the industrial machine that would replace losses faster than Japanese forces could inflict them. The Pearl Harbor attack force represented the pinnacle of Japanese pilot training achievement. Each aircrew member had accumulated over 800 flight hours through the most rigorous preparation program in naval aviation. Flight Petty Officer Shigenori Nishikaichi could navigate by celestial observation, execute dive-bombing attacks with mathematical precision, and engage multiple enemy fighters simultaneously. But Nishikaichi was irreplaceable, requiring 24 months of intensive training that Japanese facilities could not accelerate without compromising quality standards.
American losses at Pearl Harbor totaled 188 aircraft destroyed and 159 damaged, representing equipment that could be replaced within weeks using existing production capacity. But American pilot casualties were minimal, preserving trained personnel while Japanese planning assumed that destroying aircraft would eliminate American aviation capabilities. The fundamental misunderstanding reflected Japanese training philosophy that emphasized individual excellence over industrial production methods. December 15, 1941. Army Air Forces Training Command received authorization to expand pilot production to 30,000 graduates annually, representing a tenfold increase over peacetime capacity. Colonel Harold George supervised expansion planning that would establish 66 primary training schools, 36 basic training facilities, and 24 advanced flying schools across the continental United States. The industrial mobilization exceeded Japanese total aviation training capacity by margins that seemed impossible to traditional military thinking. The American response to Pearl Harbor demonstrated industrial flexibility that Japanese training programs could never match. Civilian flight schools converted to military training within 60 days, using existing instructors and aircraft to accelerate student throughput. University programs provided ground school instruction that freed military personnel for flight training duties. The civilian aviation industry contributed resources and expertise that multiplied military training capacity beyond levels achievable through government facilities alone. Flight training standardization enabled rapid expansion without proportional increases in instructor requirements.
Standardized curricula allowed civilian instructors to teach military students using predetermined lesson plans and evaluation criteria. Student pilots progressed through identical training phases regardless of which school they attended, ensuring consistent quality standards across the expanding training network. Japanese training methods required experienced military instructors who could not be rapidly replaced or supplemented. January 10, 1942. The first American pilots trained under wartime acceleration graduated from basic flying school after abbreviated 8-week programs. Second Lieutenant James Rasmussen had accumulated 65 flight hours compared to the peacetime standard of 85 hours, but demonstrated adequate proficiency for advanced training. The reduction reflected American willingness to accept lower individual training standards in exchange for increased production rates. Japanese pilot training remained constrained by perfectionist standards that prevented similar acceleration. Reducing flight hours would compromise the technical superiority that made Japanese pilots individually superior to American opponents. Eliminating theoretical instruction would undermine the comprehensive knowledge that enabled Japanese pilots to execute complex tactical procedures. Japanese training philosophy offered no mechanism for rapid expansion without abandoning fundamental quality principles. The strategic implications were becoming mathematically inexorable. American pilot training was producing 2,500 graduates monthly by February 1942, while Japanese programs maintained 125 monthly graduations across all services. The 20-to-1 production differential meant that American pilot strength would exceed Japanese capabilities within 12 months, assuming both programs maintained existing graduation rates. Lieutenant Colonel Claire Chennault observed the expanding production differential from China, where American volunteer group pilots were engaging Japanese aircraft daily. Individual Japanese pilots demonstrated superior flying skills and tactical knowledge, but American pilots achieved favorable exchange rates through superior aircraft and coordinated tactics. The combat results suggested that adequate training, combined with technological advantages, could offset individual skill differentials. February 22, 1942. Luke Field, Arizona, graduated the largest class of fighter pilots in aviation history as 247 second lieutenants received advanced fighter training certificates. The ceremony represented industrial achievement that Japanese programs could approach only by abandoning quality standards that defined their training philosophy. American methods were proving that mass production could generate adequate combat capability more rapidly than traditional craftsmanship approaches. Advanced American fighter training emphasized practical gunnery and tactics over aerobatic precision. Students learned deflection shooting using simplified methods that could be mastered quickly rather than the mathematical precision demanded by Japanese training. Formation tactics stressed mutual support and coordinated attacks rather than individual combat excellence. The pragmatic approach produced pilots capable of effective combat performance within abbreviated training periods. The technological revolution accelerating American training effectiveness included link trainers that provided instrument flight experience without consuming aircraft flight hours. Students could practice emergency procedures, navigation techniques, and radio procedures using simulators that Japanese training programs could not afford to develop or operate. The synthetic training devices multiplied effective instruction hours while reducing aircraft operating costs and accident risks. March 8, 1942. The Doolittle Raid planning revealed American pilot capabilities that differed fundamentally from Japanese training outcomes. Lieutenant Colonel James Doolittle selected volunteer crews based on demonstrated competency rather than exceptional individual skill, reflecting confidence that adequate training could prepare pilots for complex special operations. Japanese planning would have required elite pilots with specialized training unavailable to most aircrew members. The 16 B-25 crews selected for the Tokyo raid represented typical American training outcomes: competent pilots with sufficient experience for challenging missions, but not the exceptional individual capabilities that characterized Japanese aviation. Captain Ted Lawson had accumulated 340 flight hours during 14 months of training, adequate preparation for medium bomber operations, but modest by Japanese standards. The mission succeeded through crew coordination and mechanical reliability rather than individual piloting excellence. Japanese response to the Doolittle Raid demonstrated the limitations of elite pilot training when facing unexpected tactical challenges. Japanese interceptor pilots had trained extensively for conventional air-to-air combat, but possessed limited experience engaging low-altitude bombers using unconventional attack profiles. American training emphasized tactical flexibility that enabled improvisation under unexpected circumstances. April 18, 1942. The Doolittle Raid's success validated American training philosophy while exposing Japanese vulnerabilities. 16 medium bombers flown by adequately trained crews achieved strategic objectives that Japanese elite pilots could not prevent, demonstrating that mass-produced competency could accomplish missions requiring exceptional individual skill under traditional approaches. The psychological impact on Japanese aviation was profound and demoralizing. The Battle of Coral Sea in May 1942 provided the first major air battle comparing Japanese pilot excellence against American industrial capacity. Japanese carrier pilots demonstrated superior individual flying skills and tactical coordination, but American pilots achieved tactical victory through superior aircraft numbers and coordinated attacks that overwhelmed Japanese defensive capabilities. The engagement previewed larger battles where quantity would overcome quality through mathematical inevitability.
August 3, 1944, 0500 hours. The German 503rd Heavy Tank Battalion received emergency deployment orders to counter the Allied breakthrough at Avranches. Hauptmann Ernst Kessler commanded Tiger II No. 101, one of 12 King Tigers representing Germany's ultimate response to Allied 76mm gun effectiveness. These 70-ton monsters mounted 180mm frontal armor and 88mm KWK-43 guns that theoretically restored German armor superiority through sheer mass and firepower. The King Tiger represented German engineering's desperate attempt to overcome ballistic mathematics through brute force armor protection. At 180mm thickness, the frontal plates were designed to withstand any existing Allied anti-tank weapon, including the 76mm guns that had systematically destroyed lighter German armor throughout July. Kessler's confidence reflected engineering calculations that suggested no kinetic energy weapon could penetrate such massive steel protection. But Allied ordnance development had not remained static during Tiger II development. The Aberdeen Proving Ground had perfected experimental HVAP DS ammunition, specifically designed for ultra-heavy armor penetration. These rounds used depleted uranium penetrator cores accelerated to velocities exceeding 4,200 feet per second, creating kinetic energy levels that treated armor thickness as a mathematical obstacle rather than physical protection. Technical Sergeant Michael Rodriguez commanded M36B2 tank destroyer Avenger, equipped with the latest 76mm M1A3 gun featuring experimental bore treatment that eliminated accuracy problems at extreme ranges. Rodriguez had qualified as expert with the new HVAP DS ammunition, achieving penetration against test armor exceeding 200mm thickness at ranges up to 2,500 meters. The mathematical challenge facing both crews represented the ultimate test of German armor philosophy versus Allied ballistic science. Kessler's 180mm armor had been calculated to provide immunity against all existing Allied weapons, while Rodriguez's experimental ammunition had been designed specifically to defeat the thickest armor through pure kinetic force application. The German 7th Army's desperate attempt to escape Allied encirclement at Falaise created technical conditions where massed panzer formations faced coordinated 76mm gun attacks in open terrain. Over 200 German tanks, including 45 Tigers and 60 Panthers, attempted breakthrough operations against Allied positions equipped with revolutionary anti-tank capabilities. Colonel William Mitchell commanded the 823rd Tank Destroyer Battalion, positioned to block German escape routes with 18 M36 tank destroyers mounting 76mm guns and full loads of experimental HVAP-DS ammunition. Mitchell's tactical plan emphasized mathematical engagement procedures that maximized ballistic advantages while minimizing German opportunities for return fire. The German breakout commenced at 0630 hours on August 7th, when Oberst Friedrich Weber led Kampfgruppe Weber in desperate assault against Allied blocking positions. Weber commanded 28 Panther tanks and 12 Tiger Is in coordinated attack designed to punch through Allied defenses through concentrated armor and firepower superiority. Panther A-501, commanded by Hauptmann Klaus Richter, led the German spearhead with complete confidence in proven tactics that had achieved breakthrough success during previous Eastern Front operations. Richter's crew included veterans of Kursk who understood optimal assault procedures for exploiting German armor advantages against defensive positions. But Allied defensive preparations had been calculated specifically to counter massed German armor attacks using mathematical principles that eliminated traditional breakthrough tactics. Tank destroyer positions provided overlapping fields of fire across all German approach routes, while experimental ammunition loads ensured penetration capability against any German armor at maximum effective ranges. Staff Sergeant James Patterson commanded M36 Thunderbolt, positioned at optimal range for precision engagement of advancing Panther formations. Patterson's first shot using HVAP-DS ammunition struck Richter's Panther at 1,850 meters, achieving complete frontal armor penetration despite the tank's optimal approach angle. The depleted uranium penetrator core punched through 80 millimeters of sloped armor as if it were aluminum foil, maintaining sufficient kinetic energy to traverse the entire fighting compartment and exit through the rear armor plate. Richter's crew was killed by spalling effects before the penetrator completed its trajectory, representing instantaneous destruction of an experienced Panzer crew through single-shot 76mm fire. The mathematical precision of extended-range Panther penetration created immediate tactical collapse among remaining German formations. Radio intercepts revealed complete loss of confidence in armor protection. Panther frontal armor defeated at impossible range. Enemy weapons achieve unlimited penetration, unable to advance against these defenses. Desperate to counter 76mm gun effectiveness, German engineers had developed the Jagdpanzer series of tank destroyers, mounting thick frontal armor and powerful guns in fixed casement designs. These vehicles eliminated turret weaknesses while maximizing armor thickness per ton of vehicle weight, theoretically providing immune frontal protection through optimized design principles. Hauptmann Gustav Weber commanded Jagdpanzer 470, number 432, during its combat debut near Chambois on August 10th. The vehicle mounted 100mm sloped frontal armor at 45-degree angles, creating effective thickness exceeding 140mm against perpendicular impact. Weber's confidence reflected engineering calculations, suggesting his armor provided immunity against 76mm guns at all practical combat ranges. The Jagdpanzer's tactical deployment emphasized defensive positioning that maximized armor advantages while providing optimal fields of fire for the 75mm PaK-42. Weber had selected firing positions that required Allied tanks to approach across open terrain while his vehicle remained hull down behind prepared earthworks. Technical Sergeant Robert Adams commanded Sherman Fury 2, equipped with 76mm M1A2 gun and full load of production HVAP-DS ammunition that had proven effective against Tiger II armor during previous engagements. Adams had achieved master qualification with experimental ammunition, demonstrating consistent penetration against test targets exceeding 150mm thickness at ranges up to 1,600 meters. The engagement began at 1420 hours when Adams detected Weber's Jagdpanzer positioned defensively 1,600 meters distant. The German vehicle's confident positioning reflected absolute faith in armor protection that had been mathematically calculated to withstand 76mm penetration at all ranges. Adams' ballistic calculation accounted for target effective armor thickness at 142mm, HVAP penetrator performance at 1,580 meters range, and optimal impact angle for maximum kinetic energy transfer.
The firing solution required elevation adjustment of 2.8 mils and precise windage correction for crosswind conditions. The 76mm HVAP DS round struck Jagdpanzer 470 No. 432's frontal armor at the optimal impact point at 14:20:30 hours. The depleted uranium penetrator achieved complete perforation of the sloped armor, creating catastrophic internal damage that destroyed all fighting systems and killed Weber's crew through supersonic spalling effects.
American pilots entering combat in 1943 possessed adequate flying skills and basic tactical knowledge, but lacked the individual excellence that characterized Japanese aviation. Lieutenant Robert Scott had received 210 flight hours during 11 months of training, modest preparation by Japanese standards, but sufficient for effective combat performance when combined with superior aircraft and coordinated tactics. The technological advantages were multiplying American pilot effectiveness beyond levels achievable through training alone. Advanced aircraft provided performance margins that compensated for inferior individual pilot skills. Radar systems enabled tactical coordination that Japanese pilots could not counter despite superior individual capabilities. Radio communication allowed American pilots to coordinate attacks that overwhelmed Japanese defensive measures. Production statistics revealed the ultimate triumph of industrial methods over traditional craftsmanship. American pilot training graduated 58,000 pilots during 1943, while Japanese programs produced approximately 3,500 graduates. The production differential had increased to nearly 17-to-1, ensuring American numerical superiority regardless of individual pilot quality comparisons. The human cost of the pilot training race was sobering but unequal. Japanese losses represented irreplaceable individual investments in time, training, and expertise that could not be rapidly restored. American losses, while tragic, could be replaced within months using industrial training capacity that continued expanding throughout the war. The mathematical equation determined strategic outcomes regardless of individual sacrifice and heroism. Combat experience was validating American training philosophy while exposing Japanese limitations. Individual pilot excellence remained important, but sustained operations required numbers that only industrial training methods could provide. Japanese aviation achieved remarkable early successes through superior individual capabilities, but could not maintain effectiveness against opponents who could replace losses faster than they could inflict them. The final statistics revealed the magnitude of American industrial achievement. Total pilot training production reached 193,440 graduates by war end, compared to Japan's maximum output of approximately 15,000 pilots throughout the entire conflict. The 13-to-1 production advantage had determined strategic outcomes more decisively than any tactical innovation or individual combat achievement. Japanese pilots had fought with exceptional skill and unmatched individual capability, achieving remarkable tactical successes under increasingly impossible strategic circumstances. Pilots like Hiroyoshi Nishizawa and Saburo Sakai became legends through individual achievements that represented the pinnacle of aviation training excellence. But their exceptional capabilities could not overcome mathematical realities that industrial training methods had created. The legacy extended beyond immediate military results. American aviation training demonstrated industrial methods that could be applied to any complex skill development program, establishing precedents that influenced post-war aviation training and civilian flight instruction. The techniques developed for mass pilot production influenced commercial aviation training throughout the jet age. Japanese pilot training innovations influenced aviation development through tactical techniques and individual excellence standards that continued affecting pilot development programs. The emphasis on precision and comprehensive theoretical knowledge established benchmarks that modern aviation training still attempts to achieve, even while accepting industrial methods for large-scale production. The transformation was permanent and decisive. American aviation had proven that industrial training methods could produce adequate pilots in sufficient numbers to overcome any opponent relying on traditional excellence-based training. The mathematical inevitability had reshaped aviation warfare, establishing principles that would influence military planning and industrial policy for generations.